Hey, g'day, it's Presso. Thanks for stopping by. I'm working on a couple of simple side projects today. The first one is a removable way cover which fits on the y-axis of my Sieg X3 milling machine. It's made from 3D printed parts and some common materials. And the other one is a useful clamping accessory for the milling machine vise. Now it's sort of an add-on to another project I did a while ago, and I was sent in by a viewer, so I thought you'd like to see it. But let's go and look at the way cover first. Now, I bought this machine about 9 years ago and I converted it to CNC almost straight away. And one of the problems with this type of machine is that the cross slide, I'll just take this off, that's just held on by a magnet. But there's a space at the back of the cross slide here and it's open at the back. So I can reach inside there and I can feel the end of the screw. Now it's a ball screw with double ball nuts, and over time chips and dust and coolant and everything sort of migrates inside that space there. I had to take the cross slide and table off this machine just recently to do a job on it, and I found that the ball screw was completely covered in grit and caked on chips and oil, and a lot of that material gets carried over to the ball nuts themselves. Now I dismantled everything, cleaned everything, oiled it, put it back together again, but it would be better if that had some sort of protection over it so that you just simply can wipe off all of the chips without them getting into this space here. So that's where this little device comes in. It's got 4 neodymium magnets on that little bracket there, and this cross side is steel, so it just simply holds in place like that. This section here can slide up and down. It's actually in 2 parts. I'll take it off, we'll go over to the bench and have a closer look at it. One of the criteria I had for this way cover was that it's easily removed from the machine for cleaning or repair or replacement of parts. So for that reason I've made it so that it clamps onto the dovetail at the back of the column with a 2-part 3D print. So this part here, this separate part, fits into 2 slots in this section here, so that you can put the screws through the slots and tighten it up partially and then push this 3D print in to clamp onto the dovetail on the column. And when you want to remove it, you just remove one of the screws completely, pivot that part out of the way, and you can take it off the machine very quickly. At the other end there are 4 neodymium magnets, and they clamp down onto the cross slide and hold it quite firmly. Now with this part here you can still slide this up and down the column if you want to, and everything is made from PETG filament. Now I prefer to use that. I find that PLA needs storage under special conditions. If you just leave it out on the bench or on the shelf, it absorbs moisture and then it can become brittle, and when it's printing the filament can break and you end up with a failed print. So even though PLA is supposedly stronger, I prefer to use PETG because it's easier to store and you don't have to worry about it. Now at this end, the end that's got the magnets on it, you'll see that there's a slot printed into that part there. Now that's sized for this material here, which is 1.2 millimeters thick, and it just slides into that slot there, and then I drill through in each of the screw positions and put the screws right through it. And then when you tighten the screws up, it sort of clamps down onto that material and holds it firmly. Now at the other end, it's just got an aluminium strip, but you could make that out of plastic or a 3D print, and the screws go right through to the other side and they've just got nuts on them. But what that means is that the whole thing is quite durable, and I suppose you're wondering what this material is. This is EPDM rubber. Now we purchased this as a pond liner. So we dug a big pond out the back of the house and I ordered this to size, but because of the odd shape of the pond there was lots of material left over. And this stuff is great. It's 1.2 millimeters thick, it's flexible and tear resistant, but also I've found that it's quite resistant to burning from chips from the machine and also oil and coolant. Now I put the same material on my Bridgeport mill, and I did that about 6 months ago, and so far it's performing perfectly. I did have one of those Chinese made way covers on the Bridgeport, but over time it became stiff and it sort of wouldn't stretch out fully, and it was really hard to clean, and I hated it, so I ended up taking it off and replacing it with this stuff. So I did a bit of checking on various forums. A lot of people recommended this, I'd already decided to use it because I just had it in the cupboard. But yeah, in my view anyway, this stuff's fine. But the thing I like about it most is that it flexes up and doubles up on itself quite easily. You can still stretch it out and clean it. And those accordion type way covers, although they're quite flexible, I hate them because the chips get stuck in the bottom of the V's in the accordion. I think it's a useful addition to the machine. I haven't really used the machine since I fitted these, but I'll report back on it later if I find a problem with it. I've got the STL files for these parts if anybody wants them. This is for an X3 milling machine, but it might be able to be used on some of the other small mini mills as well. So let me know in the comments if you want the files. I'll make them available. Now the only thing I'm not sure about here is if these magnets are going to attract a lot of swarf and metal dust, but in reality you just put that in place and you shouldn't need to remove it unless you just want to take the whole thing off to clean it. But I guess only time will tell. But speaking of magnets, I've got another really cool magnet-based project to show you, so let's take a look at that. Now a few videos back I made a set of these balls here. Now I don't know what they're called, they don't seem to have a technical name, but these are used in the milling machine vise to put pressure against parts that don't have flat or parallel surfaces. Now I know that Chuck Bomarito makes these for sale. If you check out his YouTube channel called Outside Screwball, you'll see how he makes them on a surface grinder. I made these in a D-bit grinder just to grind the flat on one side, but you can do them on a belt grinder as well, and if you check out my video I'll show you how that was done. And I've used them and they work great. I used them on a steam engine cylinder because it had an irregular surface and one flat surface which I needed to grip up against the fixed jaw of the vise, and the ball will always put a single point of pressure against the part and transmit the force through to the fixed jaw of the vise. Now somebody else had watched that video. His name was Kurt Miller and he lives in Flagstaff, Arizona, and he sent me some photos of this thing here. He calls it a Screwy ball cap, and basically it's just a cup made of aluminium and there's a neodymium magnet in the bottom of that, and the spherical surface of the ball just goes into the cup and it holds onto the ball, but the cap will rotate a bit like a universal joint I guess, and when you tighten up the part in the vise, that ball cap will always find the optimum position against the surface of the part, even if it's curved or not parallel or tapered or whatever. And it's just another way of gripping parts that don't have accurate or reliable surfaces in the milling machine vise. Now this one is made of aluminium and I've used it and it looks a bit manky on the end there, but in today's video I'll make another one out of brass and we'll show you how to fit the magnet to make sure that it works. But I'll take you over to the milling machine vise now and I'll show you a part and how you would use this in the vise. Just for illustration, I've got a casting here in the vise here, and let's just pretend for a minute we need to do some sort of machining operation on the top of that casting. Now at the moment this surface here, which we're going to grip against the ball cap, is just a rough cast surface. It's not flat, it's not parallel to anything, and normally that would be quite hard to grip in a vise like this one here because there would almost certainly just be a single point of contact, and there's a chance that the whole casting could tip or spin when you try to put some sort of machining force on this end of the casting here because it only sits on one surface. And using this little ball cap, as you see, is a convenient way of actually making sure that it is secure. Now at the moment the back surface of that casting is not machined either, but let's just imagine that that has been machined, and that's our registration face just there. So that goes against the fixed jaw, our little ball cap. Now the magnetism from the cap does help to hold the ball against the jaw of the vise. It's not really secure, but it does hold there. And what you would do is just level that part up on the parallel at the bottom and start clamping. And as you approach and start to close the vise, the ball cap will find its correct position to clamp that part accurately. So when you get there, you just crank it up tight and we're all good to go. Now when I make the next one, the brass one, I'm going to show you a way of actually putting a little handle on it so that it sort of allows you to hold it there. And that's handy if the magnet doesn't really stick the ball to the surface of the vise jaw. Just before we go to the lathe, I want to show you this sort of cross-section drawing of what we're trying to achieve here. Now the grey part is the aluminium cup, the blue part is the magnet, and the yellow part's the ball, of course. Now if you own a ball nose end mill the same diameter as the ball, use that to make the cup seat. Now I don't have a ball nose end mill the correct diameter, so I've used a conical seat. Now that's not ideal because you get a single point of contact between, or actually a line point of contact, sorry, between the ball and the cup. And that means when you put pressure on this ball in the vise and the cup, the two surfaces here will actually Bernell. That means that they will deform into one another, and that means that this surface of the ball could make contact with the surface of the magnet. Now those rare earth magnets are very brittle, and if that were to happen, if the surface of the ball was to push into the magnet, you'll shatter the magnet and it'll come out in all little tiny bits and make a big mess. So I need to know the exact distance from the surface of the cup to the bottom of the pocket where the magnet will fit, and then we've got to leave some allowance. So what I'll do is I'm going to bond the magnet in with some JB weld, and we want some clearance underneath the magnet for the JB weld, and we want some clearance above so the surface of the ball does not push into the surface of the magnet. So I drew it out in CAD, and the dimension that I came up with is 7.9. I might even go a bit deeper than that, say like 8 millimeters, and the difference at the bottom will be made up by the JB weld. So that's where we're headed with this, but like I say, if you own a ball nose end mill, absolutely use that. It's the better way of doing it, because then you'll get full surface contact between the ball and the cup. Doing it this way, you just get a line contact, which is not ideal. Okay, let's go over the lathe. This is just a piece of scrap brass that I've got here. I want to turn this down to just under 20 millimeters. I think it's about 3/4 of an inch at the moment. So I'll face it, and then I'm going to plunge a 10 millimeter center cutting end mill down to the correct depth as shown in our drawing. Well, that's our correct diameter there now. This stock must be more than 3/4, just thinking about it. It's probably 7/8, but the diameter I'm working to there is just under 20 millimeters for a 20 millimeter ball. The exact diameter of this cap doesn't really matter. This is the tailstock DRO unit that I've got on my lathe here. Now I made a video on making this, and when I originally made it, I bought one of those really cheap calipers on eBay. It cost about $15. Because I wasn't sure how accurate and how reliable it was going to be. And I used it for a while, it worked great, and so I went and upgraded the caliper to an eye gauging EasyCal caliper. Now I've still got the original, it still works, but the battery life was very short, and also the battery cover was a bit loose, and sometimes you had to fiddle with it to get it to come alive and work. But the good thing is that everything about this caliper is the same dimensions as the other one, so I didn't have to modify this bracket which is clamped to the spindle nose to get it to work. Now what I'm going to do here is I'm going to unlock the tailstock, and we'll slide the tailstock close so the milling cutter is just near the surface there, and without locking the tailstock we'll wind the cutter in until it's touching, then we'll lock the tailstock, and then we'll zero the caliper. And now I'm going to bore in 8 millimeters, and that should be the depth of the pocket. Now on the drawing I said 7.9. We'll go that little bit extra. That will give us some clearance for the glue. Okay, so that's 8 millimeters deep, 10 millimeters diameter. Of course, you need to measure your magnet before you select the size of that bore there. So now we'll go ahead and cut the tapered seat. Now I guess the question is, how deep do you go? Now on my CAD drawing it shows that this outer flat surface here was 0.8 of a millimeter wide. Now I got no chance of measuring that. There probably is a way. I'm sure Joe Piazinski knows how to do it. In fact, I think he demonstrated a technique for calculating like measurements from tapers, but I've only got a little brain, so I'm just going to do a bit of trial and error here. I can put the calipers up there and try to measure it, but at the end of the day it's going to be a bit of trial and error. Yeah, it's more like 2, and my lathe work light's died too, so that's useless. I can't see anything. Alright, I'm going to just mess around with this. I'll try and get it closer. Okay, I've messed around with this. I think it's okay. What you should be able to do is to push the magnet into the 10mm pocket at the bottom there, and you should be able to feel that the ball is rolling around on that tapered seat. If it feels like the ball doesn't make contact with the tapered seat, either the 10mm pocket's too shallow or you've bored this tapered seat too big. Now I can sort of feel that nothing's bottoming out, but the ball is touching the surface of the conical seat there, so that's fine. I'll go ahead and I'll part this off, and then we'll clean up the other face, and then we'll bond the magnet in, and we should be good to go. Still managed to drop it. Okay, that's done. That little nib in the center there, I'll get rid of that later. So what we need to do now is to bond the magnet into the bottom of that pocket there, and I'm just going to put some JB weld in the bottom of the pocket and then upend the magnet and the ball into that, squish it down and let it set. So you can use any sort of epoxy, but I would use the 24-hour type epoxies. I think they do a better job. Now, if you want to know how much epoxy you've got to put in there, you can get something like, this is just blue tack, but you could use plasticine or chewing gum, whatever you want. I've got a ball there about 3 or 4 millimeters diameter. Just drop that into the pocket, and then we're just going to push the magnet into that and deform it. Okay, I want that sort of in the middle, there it is. Okay, I'll push that in, and then squish it down. Make sure you push it all the way down into the conical seat, and then, oh well, if you're lucky, it comes out on the magnet, but if not, you can sort of get a sense of how thick that epoxy needs to be. So I'll try and fish this out, but I guarantee it's going to deform. So there it is there. I think that's about probably 1 millimeter thick, which is ideal. Okay, I managed to get some JB weld into that pocket without making too much of a mess. It's gone around the cylindrical wall of the pocket, which is probably a good thing. Don't overdo the glue, otherwise you won't be able to force the magnet down to its full depth in the pocket there. So we'll do a trial run. If it looks like it doesn't want to go down there, we'll have to scoop some of that glue out of there. Now the other important thing is that I put some of that blue painter's tape on the surface of the magnet. I'm going to add another piece of that, just to give us a little bit of extra clearance. Oh, I should have known that was going to happen. Okay, that's got it. Yeah, it's a struggle with magnetic tweezers. Okay, so what we can do now is just simply trap the magnet against the ball with the blue tape in between, and then we just push the whole lot down. Now if there's any residual air in there, you want that to squeeze out. And I can feel that the ball is firmly in that conical seat there. So that's it. I'm just going to let that set overnight and then we should be good to go. Okay, I've let this set overnight and it just comes out of there. There's the tape stuck on the face of the ball. There's a bit in the bottom of the pocket there which I'll need to clean out. But I'll do that off camera, and then I want to show you how we can make this a bit easier to use in the milling machine vise, because this cap here is a lot heavier than the aluminium one, so it's unlikely that this whole arrangement wants to stick to the vise jaw. It will probably just fall off or slide down. So I'll make a little handle for this and then I'll meet you over the milling machine vise. On the way to the mill I checked this and realised there was some glue residue around the edge of the magnet there, so I'm just scraping that out. It's a bit tedious, but it's coming out okay. There was a bit stuck to the ball as well, but I was able to get that off in the same way. I just scraped it off. I held the ball in the same collet chuck or collet block. And interestingly, JB Weld is magnetic. So it must have like iron metallic powder in it. There's a little bit around the edge of that brass pocket there, but I think that's okay. The ball fits in there just fine and it rolls around like it's meant to, so I think we're good. Right, here's a little upgrade that I made on this brass screwball cap. I didn't do it on this aluminium one because it's lighter and it tends to hold itself against the vice jaw just using its own magnetic force. But this one slides down, doesn't stick quite so well. So what I've done is I've got a piece of 3/32 diameter brazing wire. I put a 2mm metric thread on the end of that and a corresponding hole in the brass ball cap. And that allows you to use that like a little handle, and you can lower it down deep into the vise and start tightening up the vise, just enough to hold everything, and then you can settle your casting wherever you want that to be and then tighten that up in the normal way. Now if that little handle is going to get in the way, or if it bothers you, you can just unscrew it and put it back in your box with all your other bits and pieces, and then later on you can reattach it if you need it. So I'm not saying that you need to do this, it's just a useful little accessory. Looks cute and use it or not, it's up to you. Okay, let's finish up. Well, I hope you enjoyed those two little side projects. I did actually use this way cover on the Stuart steam engine project. I had to machine some cast iron parts and it worked great. When I took it off just now, it's all nice and clean in behind that Y-axis slide. And yes, these magnets do attract cast iron dust and fine chips, but you just blow it off with compressed air and it's nice and clean, as you can see there. Now I did go to home the machine in the Y-axis and I saw this starting to close up on itself, and I nearly had an accident in my shorts. I was worried that this was going to clash, like come together and crush itself, but it pulled up just short, so yeah, that was a win. And like I say, it's kept everything nice and clean there. And these little screwball caps, I reckon they're going to be a very useful accessory as well. So thank you very much to Kurt for sending in that idea. It's always nice to get ideas for projects when people send them in. Sometimes they send photos or a picture of their workshop. Always love seeing that. And in the next episode I'm going to be back working on the Stuart steam engine project, and I've got a couple of parts that I want to show you which I think are really exciting. And it's sort of blending new technology with the old technology of traditional model engineering, but it's a direction I think we're heading in, so it's worth exploring. Now, I don't want to give too much away, but I'll give you a very brief preview. So join me for that. I reckon it's going to be super, super cool. But until then, I'll get out of your hair and I'll see you next time. It's Prezzo signing out. Cheers.